Hello everyone. Today we will discuss how to download and install the bias correction software, and further we will discuss how to use the bias correction software to convert or correct your GCM data according to your observed data. It is used both for precipitation and temperature, and there are also multiple type of downscalings such as linear scaling and distribution mapping. So we will also discuss about those. So first of all, I will let you to the website of that software, which is savat.tamu.edu. We will go to this website. So you can see the website is open. Here there are several tabs. Under the software tab we will find our required software. We'll click software. Let's see, we will find a little bit downward. Here is weather tool. We will click on this one and it will start downloading, I guess. Here you can find different user manual and some example data, and also some the CMIP5 installer. So we will install it. So this software can be used for both NETCDF files and also for files in text format. So it is a universal tool for downscaling, and we can also utilize it to extract the data from NETCDF files. And this is actually used for hydrological modeling. As you can see, its name representing CMIP5. So it is climatic model hydrology. So it is used for hydrological modeling, such as in SWOT model. If you are using SWOT and you are using some atmospheric data sets, so this software will definitely help you. So this software is actually 55.2 MB and it is in zip file format. So we will first extract these files and later on we will install it. I will guide you step by step. If you want to use it, just follow me step by step. So you can see the software is already downloaded, and we will extract these files. Just right click on it and extract to CMIP5. If you cannot find these CMIP5 extraction tools, you can download and install any zipper software to use zip files. So I have already extracted it. It is here in this folder. Just double click on it. Here our main software is existing. So just double click on it. It will ask you if you allow your software to make some changes. Just click on yes and wait for it. Here it is welcome to the CMIP5 setup wizard. Just click on next. It is in my C program files, so just click on next. And if you want to create an icon, check this box and just click on next, and here click on install. It is preparing to install and start installing. It will take a few minutes. I am just pausing my video for now. So you can see our setup has been installed. So just check if this box is not checked, just check this box to launch CMIP5. We will click on finish. So it will start launching. I mean, it will start. Our software will be open. So here is the main setup of the software, the main page. So you can see there are some options I will discuss, such as here it is PCP, and we can also use for it is TMP. So PCP is actually the precipitation, rainfall, and similarly the TMP is for temperature. So there are several downscaling, such as linear scaling. It is a multiplicative for precipitation and additive for temperature. Similarly, delta change correction and precipitation local intensity scaling and variance scaling of temperature, and similarly distribution mapping. So there are other two options. You can see NETCDF input. If your input data is in NETCDF files, you can also use NETCDF. And if you do not have NETCDF files, you can also use ASCII input. It is in text format, so it is text data. So you can see there is in ASCII input setup, they are asking for historical data and future data. So for bias correction, using this software needs historical data, observed data, and also future data. So if your observed data is overlapping with your historical data, actually historical data is of the GCM, and future data is also GCM data. So your historical data must be overlapped up to 80%, or it can be 100% also, but for accuracy it must be greater than 80%. The time period of your historical data and the time period of your observed data must be overlapped up to 80%. I mean to say, if you have the historical data from 2000 to 2010, so you must have the observed data from 2000 to maybe 2008 or maybe 2010. So the time period of your historical data and the time period of your observed data must be overlapped. So if the overlapping is more than 80%, then it will give you the accurate results. Otherwise, this software give you poor results if you are not overlapping, or maybe it will not work if you do not overlap your observed and historical. I will discuss later in some example by showing my data sets. Here are my observed data, such as Pag and Balaghat and different station, and I have a master file such as PCP4. You can see it. There are some ID such as 1, 2, 3, 4, 5, 12. So there are 12 stations and their names such as Balaghat, Karilbatta. You can see the name Balaghat is the name of the file which is containing the data, such as you can see Balaghat here. So Balaghat, the spelling must be same, and its latitude is 34.6, and similarly longitude is 73.4, and its elevation is 996. So these all things must be given if you are going to use the CMIP5 software. So you need to prepare these files. Same. If you have any queries about preparation of this file, you can ask me through my email or my WhatsApp. Okay, and I'm just showing other NetCDF files. Here are also some temperature data sets. So the name of first file containing the temperature is 2901 TMP, and you can see from here it is same. The name must be same. So station first name is TMP 2901, and similarly here it is TMP 2901, and same rates, latitude, longitude, and elevation. Before going to NetCDF files, let me check show you my data files. So you can see it is written as 1981-0101. So this data is starting from 1st of January 1981, and it is till 2010. So this data is approximately 30 years. Observed data is 30 years. The more observed data will produce you the better results. For my GCM data, you can see it is a had GEM2 model, and you can see also this one had GEM2, and had GEM2 we have 4.5 and 8.5. Under 4.5 we have precipitation and temperature. Precipitation, you can see there is historical data from 1981 to 1999, and similarly the future data is from 2075 to 2099. So it is almost 25 years. So if you are using NetCDF files, you can do it by a period of 30 years. You can use the downscaling techniques for a maximum of 30 years, and you can also repeat this process if you are using longer periods, such as if you are using for 100 years, you can divide the 100 year into 3 time span, such as 30 year for one run, and 30 year for second run, and similarly 30 year for last run. So I'm just running it for 25 years using some historical data and just an example. So we can just opening our model. So here you can see the main tab of our CMIP5, where we can select PCP and select location file, and in location file I have already showed you the master file PCP4. I will open it. So after selecting this file, you need to wait a bit. Then here my stations and my data from 1981 to 2010. So it is observed data. Similarly, you have to choose the method of downscaling, such as linear scaling or delta chain correction. For this time example run, we are using linear scaling. So after selecting your master file and your observed data in this tab and in this box, you have to go to climatic model data. You need to select NetCDF. So as I already showed you, under head GCM2 we have 4.5 under PIA. We need to select the entire folder instead of selecting some files. Here again we can show you head GCM2 here, and under 4.5 precipitation, and there is no folder inside it, so we will select the entire precipitation folder. So after selecting this folder, the all files, mean to say historical and future data that was placed in that folder, will be appeared here. So you can see it had GCM2 model and historical and RCP 4.5 for future. So click here and we need to select RCP 4.5. So after selecting RCP 4.5, you can see this box is filled up above and representing some sort of historical period. You can see here from 1988 to 1997, and similarly some future periods from 2075 to 2099. So after doing this, you need to select the folder in which you want to save your results. So I'm just selecting bias collection. I have placed it on desktop. I will select this one and I will click on check files. After clicking check files, it will take few seconds to do all these simulations. Later on you can see results. First it will check these files and tell you about the overlapping period and some other things, such as you can see it is only overlapping 32.86, but 100% is overlapped. Mean to say your historical data is completely overlapping your observed data, and on the other hand your observed data is bigger and your historical data is smaller, so it is the overlapping percentage of observed on to historical is 32.86. So I will just use only overlapping period to calculate, and I will check this box and click on start process. So after it will wait for a few minutes. I mean to say not minutes, it will take a few seconds maybe, depending upon the efficiency of your system. If your system is has more abilities, such as it is a supercomputer, it will take a few seconds. Depending upon the RAM of your computer, your period of working will be greater. Mean to say, if you are using 4 GB RAM, then you need to simulate almost 10 to 15 years and for one run, and simulate 10 to 15 for other run. It also depends upon the size of these NETCDF files, because some GCM models have contain a lot of space, such as this NetCDF is having 2.86 GBs. I mean, the data is much bigger. So depending upon the size of data, your working speed will reduce. So after few seconds, it will turn the box will turn into this one. You can see these. So after this message appears, you need to minimize this tab, and also you need to check your folder in which your output will be stored. You can see here Precipitation folder, PCP. Under Precipitation folder there are two more folders, such as GCM2 and Observe. So under GCM2 you can see linear scaling. So on the top folder, linear scaling, is your results. You can see RCP 4.5. Under RCP 4.5 there are 12 different you can see different text files. So each file is representing one station. So let's suppose in PCP first station, we will check it how did it look. So it is actually starting from 2072, and it will going to 2099. Similarly, second folder, second file is also starting from the same date. So in this way you can extract your data from NetCDF files, and as well as you can use different downscaling to get the station-wise data of GCM from GCM. Thanks for watching my video. I hope this will you will get some benefit from it. If you have any further queries, you can just message me in my WhatsApp or on my email. I will try to reply as soon as possible. Again, thanks and bye.